Another great way to control the center of gravity without having it focused in just one place is to marry two different materials together. For example, here I've got a lure that's fashioned after an old bait called a burmick. This orange part you see at the bottom is a regular Luma light resin. It's heavier than water. And on the top, I've got a strong structural foam. Call it a Luma foam. It's great for making lures and crankbaits because it's real tough and real buoyant. By distributing the material in this way, I can put this in the water and it'll always whoop right straight over, and its weight is equally distributed on the bottom, causing the center of gravity to create a keel. Here's a wing shape I'm playing with. This is micro balloon loaded aluminite resin, and then I've loaded the very bottom of it with tungsten powder. And I can mess with that shape in a whole bunch of different ways. I've created, this one's 10% by weight micro balloons, weighs 129 grams. So I'll mess around with this shape and just see where it leads me. But I'm beginning with controlling my specific gravity and controlling my center of gravity, and then I'm going to play with shape. We're talking about center of gravity. It affects so many different things in many different ways, so it gets a little bit complicated. But one of the best examples to sort of show how center of gravity and balance make a difference are in zigzag baits. Here's a shape of a very good floating zigzag bait, but most of them are basic torpedo type shapes. But I could take any of these shapes and change the action radically by simply changing where I put the center of gravity. This particular bait, I can even just hang it loosely and bam, it drops to the back. All of the lead, there's probably 3/4 or a half an ounce of lead right in the tail of this lure. It's a topwater lure. It has high buoyancy. When you work this bait, you can get it to maybe zigzag this far. Go whew, whew, whew. Just nice as you can please without a whole lot of effort. The other thing you'll notice where the connection point is. But primarily, it's all about balance. I've taken the rear hook off where a fish did of this little rascal. And you might think that because it's fat in the back and skinny in the front that it would, float like so. But no, it's got all the weight in the back. It actually sits like this. It's got, and it's a little less buoyant. But anyway, this thing sits in the water like so. Absolutely no glide at all, but it goes whoop, 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 and it becomes a slapper. I could take a teardrop design, and if I put this in the water, you'd see that it doesn't sink tail down, it doesn't sink head down, it sinks almost perfectly level. And the lead is up front, but that's simply to compensate this. There's more buoyancy in the head than there is in the back. And if I take this lead out, this bait would actually be tail weighted in the water. But by creating lead where it balances and having the hooks so it doesn't affect the balance either, I've got a bait here that if I do it just right, get my timing just perfect, I can make a zigzag many feet left and right, and even do it underwater. So both balance and center of gravity. Huge difference. When I was making a crankbait, a little fella like this, probably want to figure out where this thing wiggles, and I'd want to put my center of gravity right at that pivot point or right at that node. Unless I wanted the bait to act a little weird, then I might put it forward or back. Center of gravity, big deal.